So now we're getting into chapter 4. Yes, we are skipping chapters 2 and 3 for now. We will eventually come back to those. The reason why we needed chapter 1 is because you needed to understand the concept of domain and range as well as the graphing concepts before we get into the trig section. Suggestion to take the ACT, seniors, either October or December. Preference is probably December.
Or both.
Just because, or both, right? Just because in December, you'll have had almost everything with respect to trig that we can go over.
What is that?
And so,
I'm already taking this September.
so now what we're going to do is we're going to talk about the right triangle trigonometry. You're going to realize, those of you that had geometry 2 years ago, that this is going to be reviewed today. And you've seen this stuff. It should be pretty familiar. The nice thing about this stuff is it's very applicable to what's going on in the world. I think some of you will really like this. And so first of all, trigonometry means triangle measurement. That comes from the word trigon, which means triangle. Metry, which means measurement. Okay, so trigonometry means triangle measurement. The key concept box here from your book, trigonometric functions, okay, actually should look very familiar. Okay, you should already remember this stuff because we had a nifty little way to remember the trig functions. SOHCAHTOA, right. And so that's all this is. Now you're going to notice that there are 3 other functions there. There is cosecant, there is secant, and there is cotangent. So if you want to follow along in your book, it's found on page 220 if you're having trouble seeing the board. But what I want you to do, okay, is we know that sine is abbreviated SIN. Theta just means an angle. So sine of angle, an angle, is opposite side over hypotenuse. Okay, cosine is adjacent side over hypotenuse. Tangent is opposite over adjacent. And so if you look at our diagram, our right triangle right here, what I have done is I found angle theta. Based on angle theta, I've labeled all the sides. Remember, I have my opposite side, which is the angle opposite the angle. My adjacent side touches the angle, and my hypotenuse is always the side opposite the 90 degrees. What else do you know about the hypotenuse in general in comparison with the opposite and adjacent sides?
Longest.
It's the longest side. So your hypotenuse is always your longest side. So sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. You are going to want to make sure, at least for today, that your calculator is in degree mode. If you want to know how to get to your calculator mode, you're going to go to the mode button. Okay, if you hit mode, your mode is located right up there by the blue second key. It should say RAD, radians or degrees. You want to make sure you're in degree. My guess is you're probably in radian mode, so change that over to degree. So go to mode, which is right by your second key. Okay, make sure you're in degree. Yep, it's the third one down.
Oh.
Okay, so make sure you're in degree mode first of all. Okay, we will eventually learn about all the radians and all that good stuff. Okay, the other thing what I want you to do is I want you to go ahead and look up here at my other 3 functions, and I briefly mentioned those earlier, cosecant, secant, and cotangent. Okay. Yeah, and that's what I wanted you to do. I want you to compare cosecant, secant, and cotangent versus their 3 over here, sine, cosine, and tangent. What do you notice between those 3?
Opposite.
When you say opposite, elaborate.
Like the
Inverse.
Yeah, so basically it's the reciprocal or the flip. So another way I could write cosecant would be 1 divided by the sine of theta.
Did we do that?
What would be the same with secant? How else could I write that? I don't remember if you have or not. 1 over cosine. What can you tell me about cotangent? 1 over tangent. There's also another way. Okay. Now I don't know if we've ever written this down. Tangent, we can find tangent by taking the sine and dividing it by the cosine. We can take cotangent by finding the cosine divided by the sine. Now you're going to want to file those away. Now the thing about these last three that we've just added, the cosecant, secant, and cotangent, your calculator does not have buttons that say cosecant, secant, and cotangent, okay? Mainly because they're related to sine, cosine, and tangent.
Is this like the negative one thing?
No, these aren't the negative ones. These aren't the inverses, and we'll get to the inverses, but these aren't the inverses. These are a little different. So today, all we're going to be doing is solving right triangles. That's it. So let's go ahead and look at an example. Find the exact values of the 6 trig functions.
Should assign one to each table.
So if you look at this, I have my right triangle here, 8, 15, 17, so I already know all the sides. Now what I need to do, very first thing, I've got my angle right here. I'm going to go ahead and label all of my sides. So first side that you should be able to label would be the hypotenuse. And what's the hypotenuse?
Across from it.
17. Okay, it is across from the 90-degree angle. What side is the opposite? 8. What side is the adjacent? 15. Now, you might not need to label those. I'm just doing that for somebody that's maybe watching the video and wants to understand where those come from. And now, there's my angle. I know that sine equals opposite over hypotenuse, because that's your SOHCAHTOA, opposite over hypotenuse. So all I'm going to do is fill those values in. The opposite side is 8. The hypotenuse is 17. Now, you do need to reduce those down if you can. This one doesn't reduce down. Okay. Cosine, you know, is adjacent over hypotenuse. So in this case, what would cosine be? 15 over 17. Good. Can you reduce it? Nope. Yep, 17's prime. That's right. Tangent. What's tangent going to be? Opposite over adjacent. So what's that going to be? 8 over 15. Now, if you remember on the very first page, I wrote something else by tangent. What was that? Sine over cosine. So another way you could find tangent would be to take 8/17 divided by 15/17. And believe it or not, your 17s are going to cancel and you're going to have 8 over 15. Now, cosecant, on the other hand, this is why it's so important to get the first 3 right. Because all you're going to do with cosecant is switch them. So cosecant will actually be 17 over 8. Secant will be 17 over 15. Now, if you're wondering where I'm getting those, for cosecant, I look at sine, 8/17, you flip it. For secant, I look at cosine, 15 over 17, I flip it. Cotangent, I look at what? Tangent, and I flip it, and so I get 15 over 8. All right, so that's the 6. Now the thing about these come test time, this is like 6 points.
That's easy.
Okay,
That's
so
like
yeah,
6
that shouldn't be
punches
bad
in
at all.
the
It's 6 points. So do we have any questions on that? Let's look at another one. Now this is a little different because this tells me that cosine of theta is 2/5. Now I want to find the exact values of the 5 remaining trig functions because so far we have a total of 6, and I've already got one that I'm given. Okay.
We're gonna have to do that.
So now, a key suggestion would be right now to kind of make a little answer key for yourself so that you know what to fill in. So the first thing I would do is I would go ahead and start by writing sine theta, cosine theta, tangent theta, and then I would go ahead and write their partners. What does sine go with? Cosecant, yep, CSC. Cosine goes with secant, tangent goes with cotangent. Now by doing that, I now know what I need to answer.
Not the cos.
Okay, so now in the problem, I've already got 2 answers right now that I can answer real quick. Okay, you know that cosine is what? 2/5. So then that also tells me that secant is
5/2.
5 over 2. So see, just by doing that, just by the problem, not even doing really any work, you've already answered 1 of the 5. So now what I need to do is draw a triangle, and I already see some of you doing that. Okay, and that's exactly right. I'm going to go ahead and draw a triangle now. Okay, now notice this does in fact have to be a right triangle. And in that right triangle, I need to go ahead and figure out what my sides are. So I'm just going to pick theta of the 2 remaining. It doesn't matter which one. I could put theta even either here or here. I know that cosine is 2/5. So if theta is right here, what is my adjacent side gonna be? The horizontal or the vertical?
Vertical. Oh, you said
What's the-
adjacent.
Adjacent.
That's horizontal.
That's the horizontal. Where does the 5 go? On the diagonal. So now we got a problem, and what's our problem? We have to find the vertical
How
side.
did you know
That's
your
not really
theta was in that
wrong.
corner though?
I said you could have put it here or here.
Oh, okay.
Okay, it doesn't matter. So now we have to figure out how we find that vertical side. So what could we use?
40, 40, 90, or the
Mhm.
30, 30, 90.
What would be a way I could find this
Would be
vertical
two.
side?
Well, it's that, whatever that one thing's called, a squared, b squared, c
A
squared.
squared,
A squared,
Pythagorean.
Pythagorean theorem, very good. So we're going to go ahead and do that. 2 squared plus, I don't know what we want to call that. What do you want to call it? A
X.
squared?
I would check
X
that.
squared, that's fine, equals 5 squared. And now I need to solve that. Now you're gonna find that these aren't gonna be perfectly whole numbers. There's probably gonna be some square roots involved, and that's okay. So I get 4 plus a squared equals
25.
25.
So it'd be 20.
What do you get a squared equal? 21. What do you do now?
That's the square root.
Square root. Now one of the important things to remember here is if you can simplify root 21 down. Can you? No, it's as simple as it
Unless
is.
you want a decimal number.
Yeah, and we don't do decimals.
Oh.
You're going to find out that when we do that, whenever it says find the exact values, and that brings up a good point, thank you. Whenever it says find the exact values, that means no decimals. Now I know some people think exact means decimals, it does not. So now all I need to do is fill in what I know. What will sine of theta be?
Square root
Yep.
21 over
Oh, what pen? Let's go back.
That's bad.
Okay, root 21 over 5. So now what's cosecant?
21.
Okay,
Fine.
you're not gonna be allowed to have that. Okay,
So square root of 20.
perfect. Yep, 5 root 21 over 21 is the answer that you need to have. Okay, so it's not a bad thing to have this 5 over root 21 written though, because eventually when we start solving some other problems, that makes it a lot easier to have that written somewhere. What's tangent gonna be?
Root 21 over
Root 21 over 2, good. So what is cotangent?
2 root 21 over 21.
Okay, it's gonna actually be 2 over root 21, and some of you have already simplified that, which is great. 2 root 21 over 21, and that's gonna be your answer. Okay, think you can handle that?
I think I could possibly, I could do that.
Okay, so now, the next thing that I want you to do is you're gonna need to write these down, this 30, 60, 90. Now, we're gonna get to a 45, 45, 90 as well. And then I think we'll probably call that good for today, and then we'll pick up with this tomorrow and finish tomorrow. Okay, but the 30, 60, 90 triangle, you need to remember the relationship between all of the sides.
So right this full triangle.
That would probably be a good idea to have this written down somewhere. Now notice, remember this is just our right angle. Now this applies to any 30, 60, 90 triangle. They will all have this relationship.
Alright.
Now, if you know the shortest or the longest side, that's the easy one because look at the shortest. The shortest side is always opposite the 30. It's just by itself. Okay? The side opposite 60 is root 3 times your shortest side. And the hypotenuse is double your shortest side. So in this problem, if I told you that that is 5, that's my shortest side.
That one would be 10.
This one would be 10, good. And then this one would be 5 root 3.
I really don't get that because
It's your shortest
60
side
is
times root
double
3.
30, so why isn't the side?
It's not in that proportion, you can't go by angles. Now, test time. You forget the relationship between the two. So let's just think about that real quick. You forget the relationship, you're like, crud, I don't know what to do. You're not out of luck. all you have to do is go through and use the Pythagorean theorem.
Oh, that's good.
Anytime you know 2 of 3 sides, use the Pythagorean theorem. If you forget that relationship, there you go. You should get 5 root 3. So let's try another one. Okay, and then we'll get to the one that nobody likes. So let's try this one. Let's see that this one's 14.
That'd be 7.
So the shortest side is
7.
7. The other side is 7 root 3. Now,
Oh, I love this one.
let's do 6 right here.
So,
Now let's think. The relationship between this one was that I take the shortest side times root 3. So down here, I'm going to divide by root 3 to go backwards. So really, this is what it's going to be. Now, of course, you know, I
So you
can't.
get a root 3 at top and over
Yeah,
3.
so you got to get rid of the root 3's here. So let's multiply by root 3, root 3. You end up getting 6 root 3 over what?
3.
3, which is 2 root 3. Good. So that was kind of a pain. What's the hypotenuse going to be?
4 root 3.
4 root 3.
you just take that number.
Doubled it. Yep, you double it.
The square root.
Okay, so that's 30, 60, 90 triangle. Now eventually we're going to talk about sine, cosine, and tangent. We're going to do that tomorrow. Okay, of the 30, 60, 90 triangles. And then the last thing we're going to talk about today is the 45, 45, 90 triangle. The nice thing about the 45, 45, 90 triangle is that you can always use the Pythagorean theorem on this problem. You can always use the Pythagorean theorem on this problem. No matter what. If you know any one side in a 45, 45, 90 triangle, the Pythagorean theorem will work.
That's crazy.
So let's talk about why that works. Okay, now obviously it's not the most efficient. I mean, come test time, I'm going to expect that you know the relationship. And so I'm going to build the test around that fact. So you don't want to spend your whole time doing Pythagorean theorem, you'll run out of time. But let's go ahead and look at this. Okay, if I know that that is 10, all right, you could use the Pythagorean theorem. You know that each of these sides are the same, so you could do this. A squared plus a squared equals 10 squared. You could do that, because you know that they're both the same. So you'd have 2a squared, for those of you that weren't kind of, how would you solve that? You'd get 100. And so then a squared would equal 50, and you'd be able to take the square root and solve it. That's one way. Okay. Yeah. Or on this one, how do you find the sides by just looking at the 10?
Divide by root 2.
Divide by root 2. Very good. And so then now all we need to do is simplify that. Okay, 10 divided by root 2. Remember, we need to multiply by
Root 2 would be 5 root 2.
root 2 over root 2, which is 10 root 2 over 2. And as somebody's already said, you've got 5 root 2. So now let's look at it again. We got that one now. So here we go. If I know that this side here is, I don't know, what should we say, 7?
11. Oh, man,
7?
711.
What's this one going to be?
7.
7. And this one will be
7
7 root
root 2.
2.
Yeah, this like is way easier than it was 2 years ago.
The reason why it's easier than it was 2 years ago is 1, you're older, and 2,
Be
this
smarter.
is the second time you've learned it. Anytime you learn something the second time, it's much easier.
I don't know if I actually learned
And
it.
so-
we just
So
throw
this
our
will be
heads
the
in
whole
the
process.
hot
That's
water.
kind of
That's the last.
You might not get it.
Hot
So
wash.
this-
So the nice thing is when we start talking about domain and range with the sine and cosine curves, that will be the second time around that you've learned it. It'll be a little bit easier there. Okay, so now I'm going to go ahead and skip through these slides. So if you're watching, I'm sorry. If you want to go ahead and start working on your assignment, this is what you need to start working on. Page 227, 2 through 42 the evens, 48 through 54 the evens. Now obviously you're not going to be able to go through a whole lot today, but we will continue more with this tomorrow. Tomorrow we're actually going to solve right triangles. Tomorrow we're going to be solving right triangles when we know angles, when we're know sides. And so anyway, we will finish this tomorrow.